Okay, so question 4. A 3 kg brick is released from the top of the building. Calculate the velocity after 1 second. Okay, now to calculate the velocity after 1 second, we're talking about, no, this is the question, it's question 5 that I want us to do. Sorry. A rock of mass 200 kg is dropped from a height of 200 meters. What is the potential energy and kinetic energy at that? So of this situation, we have this height, okay, of 200 meters. Then there's a rock here which has been dropped, right? So now they want us to know the potential energy and the kinetic energy at 0 seconds. So potential energy is easy to calculate. We just say potential energy is equal to mgh, right? So m, we know is 200, right? Is it? Yes. G is 10 and height is also 200. So 200 times 10, 2000. 2000 times 200, it will be 400,000, right? 400,000 joules. Okay, let me just confirm. 200 times 10, 2000. 2000 times 200, 4,000, 400,000. Yes. Okay, so now this is the potential energy. Okay, so the kinetic energy at the top, it's always 0 joules. Okay, now there is a concept which is called the conservation of energy, which says energy cannot be created or destroyed, but it can be changed from one form to another. So in short, or mathematically, it means the total energy of a system never changes. Okay, so in short, in this case, total energy is equal to potential energy plus kinetic energy. Okay, potential energy, we know it's 400,000 plus kinetic energy 0. So the total energy is just 400,000 joules. Okay, so 400,000 joules. This is the total energy. Okay, so now why are we finding the total energy? Because once we know the total energy, we will be able to calculate the energy at any point other than the top and the bottom. The top and the bottom, it's easy, but in between it gets complicated, right? Here it's easy, here at the bottom it's easy, but in between it gets complicated. Okay, so we need to know the total energy. So to find the total energy, you calculate the potential energy here, and of course the kinetic energy is always 0. Then when you add them, what you get is the total energy. In short, the potential energy here is the total energy. Okay, now as this rock of ours is falling, the potential energy will be turning into kinetic energy. So we're going to have this scenario. Okay, let me see. So we're going to have this scenario. So if the rock is on top, it has 400,000 joules of energy. That 400,000 joules of energy is potential energy. Kinetic energy is 0. As it is moving, at some point, the total potential energy will reduce. Maybe from 400, it will become 300. Well, the kinetic energy will start increasing from 0 to something. Okay, that's how it works. Now, let's try to get at 2 seconds. All right, so at 2 seconds, what's the potential energy? The problem is we can't tell what the potential energy is because we don't know the distance. After 2 seconds, it has moved, maybe it's here, but we don't know the distance from the ground to this point unless we calculate. Okay, so we can use the equations of motion to know how much distance it has covered. Okay, or the other way, we can try to find the velocity at this point. Okay, what velocity does it have at this point? We know that the initial velocity here, it was at rest, is 0. The acceleration for anything that's going down, it's 10, right? And the time, it's 2 seconds, right? So we can find the velocity after 2 seconds. Okay, we can say v is equal to u plus at. So v is equal to u0 plus acceleration 10 times time 2, right? So the velocity is 20 meters per second. That's the velocity at 2 seconds. Now that we know the velocity, we can use this velocity to find the kinetic energy. which is half mv squared. Okay, so it's half, the m is 200, the v is 20 squared. Okay, so we get a calculator. We're going to have I don't want to get a calculator, but I think we're going to have 40,000. We're going to have 40,000 joules as kinetic energy. Okay, so when you solve, our kinetic energy is going to be 40,000 joules. Now look at what happens next. Okay, so now we have the kinetic energy as 40,000 joules. Okay, is it 400,000? It's 40,000 joules, right? Then the total energy, remember the total energy, it was 400,000 joules. Okay, to avoid problems, you can, instead of writing 3 zeros, you can be writing K. Okay, like 40K joules. The K means 3 zeros, right? To avoid the wasting time as you are writing. So here it's kg, kj, and here to be kj, right? So now the total energy is potential energy plus kinetic energy, right? So the total energy 400 kilojoules, potential energy plus the 40 kilojoules, which is kinetic energy. You can bring the 40 here, then it becomes 400 kilojoules minus 40 kilojoules. Okay, that's your potential energy. So 400 minus 40, 360 kilojoules. That's your potential energy. So what we have done is we have used the time to find the velocity. After finding the velocity, we have used the velocity to find the kinetic energy. Then after finding the kinetic energy, we have subtracted the kinetic energy from the total energy. The energy that remains is the kinetic energy. Okay, it means you are done. So this is how to solve on all the stages. Question, if we go to C, it is asking about 4 seconds. What is the potential energy and kinetic energy at 4 seconds? The procedure is the same. First, find velocity at 4 seconds, okay, which is going to be something like maybe 40, right? Yeah, 40. Then use the velocity to find the kinetic energy, okay? Use the velocity to find the kinetic energy. Okay, let me just demonstrate, but it's the same procedure, okay? So you say V is equal to U plus AT, right? So V, U, it's 0, plus acceleration is 10, time is 4, so it's 40, right? Then use this velocity to find the kinetic energy, which is half times m, which is 200, times 40 squared. Okay, so this and this goes, this is going to be 100 times 40 squared. Is it 40 squared? Yes, 40 squared, it's going to be something like 160,000, something like that, maybe 160 kilojoules. Okay, so once you find the kinetic energy, you subtract it from the 400,000 joules from the total energy. The total energy never changes. Okay, so once you find your kinetic energy, you subtract it from the total energy. Okay, so what you're going to remain with is the potential energy. So that's how to do it. D, just before it hits the ground, it's easy to calculate. Why? Because just before it hits the ground, potential energy is 0, because the height on the ground, from the ground to the ground, is 0. So the potential energy is 0. You don't have to know the time for you to find the velocity here. Okay, the potential energy is 0. Why? Because height is 0 from here to here, since the rock is here. So it's going to be potential energy mgh. The h is 0, so it's going to be m times 200 times 10 times 0. It will give you 0 joules. Then now this 0 joules, you subtract from the total energy to get the kinetic energy. So in summary, I may be fast because it has taken time, about 11 minutes or so. Yeah, but I hope you have got an idea. So in summary, what I'm trying to say is, at 0 seconds, potential energy, use the formula, kinetic energy is always 0. At 2 seconds, use 2 seconds to find the velocity, then the velocity, use it to find the kinetic energy. Then the kinetic energy you subtract from the total energy. The total energy is the potential energy at 0. Okay, so the potential energy was 400,000 joules. That is the total energy. Okay, so now at 2 seconds, you find the kinetic energy, then you subtract that kinetic energy from the total energy. What you remain with is the potential energy. Here, you do the same. Just before it hits the ground, potential energy is always 0. You don't have to calculate. Potential energy is always 0. Then the total energy becomes the kinetic energy, because total energy is equal to potential energy plus kinetic energy. Okay, so that 400 kilojoules, potential energy is 0, so plus kinetic energy. You don't need to know the velocity and the likes. So the 400 kilojoules becomes our kinetic energy.